In this clip, we will begin with building up the point vault that we created in the previous clip. Let's visualize it, go inside. Let's drop down a vector to float and a float to vector. First the vector to float and a float to vector. We can wire up X and Z, and we wire the position of the globals into the first vector to float. Let's copy this one again. So we have a second one. That one goes into the color, CD, because we want to get the red value from there later onwards. Let's drop down and add. And what we're going to do is we're going to be adding the red value to the Y position. So first we pipe in Y, and to that we add red, and that we pipe back into the Y. And the output of that goes into the new position. We want to create a bit of space here. Let's drop down a multiply and create a parameter. And the parameter we can call multiplication factor or mult factor. And what that's going to do, that's just going to be a value. Let's set it to 1. That's going to multiply that red value for us so that we can have a play with that if we want to. And that should be that node setup for us. Let's go back out. And now in theory, if I paint on this node, we should see that this one will move up. So let's template the CR to height node, visualize the paint node, and paint on there. Holding down Shift and dragging with your left mouse button will scale it up, the brush that is. Let's see how we go. So it is translating it in Y, but only very briefly. Again, the scale we're working on is huge. And we're only adding 1 to the value right there. So on this VOPS up, we have that multiplication factor, and let's just multiply it by 20. So now we're displacing the geometry where it's red. Now with the paint, anywhere between 0 and 1, we can scale the red values that we're using. And by that, we can scale the height that we're adding to this grid. It's a bit slow for me, so I'm going to reduce the remesh. I'm going to set the target edge length to 1. And that will ruin my paint, so I'll have to start over. But better do it now than later. So that's a lot quicker for me already. Let's create a few red spots, just so later we have some visual feedback. I'm just sort of guessing where our point cloud is going to be. That's where we are, right? So I'm painting roughly where the tall buildings will be, as they are the ones I want to be stacking. There's no point in painting the houses. So what we're going to do now is we're going to drop down a ray node. And once we have the ray, we're going to wire the red into the right input. And the other input is going to go into the outclean point cloud. And on the ray, we want to configure it in a certain way. Let's drop this down a bit so we have a bit more space in there. The ray direction is going to be up in Y. So let's delete the channels and in Y type 1. Let's look at the points. So we can now see that some of these blue points are being rayed up. So they're sort of sticking to the ceiling that we're creating. And what we're going to be doing is we're going to be transferring that height data back into the original point cloud. The reason I'm using this technique specifically is because it makes it very visual. So we can see exactly how tall these buildings are going to be. And that makes it artist friendly. So let's create an attribute. Let's drop down an attribute create. Wire that in. And expand our top window a bit. The attribute we're creating is going to be called skyline underscore height. It is in fact a point attribute. It's going to be a float. The only thing we're going to be changing on this node is the value. And in there, I'm going to type an expression. And what I'm going to be doing in that expression is comparing the position of the points on array 1 to outclean point cloud, which is flat, and subtracting those. So let's select attribute create 1, expand our value window with Alt E, and in there we type an expression. It is as follows: point, open and close brackets, and in between there we are going to be looking for array 1, This is up one level, array 1, and you can see in the drop-down menu that it appears. We add a comma. We want to get $PT for each point. What we want to retrieve is the position attribute, so string attribute P, and we want the first index. Why? Because X, Y, and Z will be 0, 1, 2, and we want the Y attribute. And then we want to subtract the positions of outClean point cloud. Open and close brackets, and quotation marks, out underscore clean point cloud. We can already see it in the drop-down. We want, again, $PT, the P attribute for position, and the first index for Y. We're going to hit apply and accept, and it is complaining. I forgot to add the word point here. We want to make sure that allow local vars is ticked. That's all good. And now if we right click, go to the spreadsheet, we should be able to see a skyline attribute. Let's see, skyline height, there it is. And if we filter that, we see that we have some at 20 and then going down all the way to 0. And the ones that have a higher value than 0 would be where we painted. This expression would work as well with just the first part. So if we just isolated this part, we would still get the Y value of each point in here. But using this entire expression, it doesn't matter whether or not this is actually at Y0. So if we would have this base point cloud translated up to a higher value, it would still be correct. Whereas if I'd only used the first half of the expression, it would be incorrect and we'd get weird things happening. So that's why it's this way. Let's drop down an attribute copy. We wire attribute create 1 into the second input, and the first input goes straight into outClean point cloud. What we want to do is get our Python node and drag it down and wire that into our attribute copy. The attribute copy we want to configure, so let's select that node. We want to transfer skyline height. So now if we look at the spreadsheet, we should still have these values of skyline height on our points, even though our actual points are no longer floating in the air, but they're all set at 0. And what we can do with this data is define how tall each building is going to be, and thus how many points we're going to have to stack upwards before we reach that height. We are now ready to start coding.